Our second lesson continues on with the first, in that we're looking at surface area, but today we're looking at surface area of cylinders, cones, and spheres. And that's going to be our key idea. So all of the shapes today are curvy. All the shapes last lesson were straight line stuff. Whenever you have curvy shapes, like circly stuff, we're going to have pi in there. If you have a pi button on your calculator, you can use it, or you can approximate it with 3.14. So we'll start off with cylinders. Cylinders are nice, easy shapes because they really only have two things. They have a height and they have a radius. And that will come into play in our formula. The other thing about today, all three of these shapes have a formula. Unlike last day when we had to put things together from grade 8, grade 9, grade 6, today every shape has a formula. You don't have to memorize them. You'll have a sheet or they'll be given. So some examples of a cylinder would be something like a soup can, tennis ball container, and a spaghetti holder. So that's what ours looks like. It's like a cylinder. So lots of other things that are held in cylinders. Soup can, as I said before. So here's the formula, and the formula is going to include H and R. So I'm going to give you the formula, and then we'll talk about where it comes from. So here is the formula for the surface area of a cylinder. And this part is the formula of two circles. So pi r squared is the formula for a circle. And this is really the top and bottom of this cylinder. So top and bottom would be that, two circles, 2 pi r squared. And this part of the formula is the side. And it's also known as the lateral side. So if you imagine a toilet roll, toilet roll doesn't have a top and a bottom, it's hollow. But if you imagine a toilet roll, we'd all say that was a cylinder. Well, if you cut a toilet roll, so I'm just going to make a cut on my little picture there. Say we cut this cylinder right there and we unrolled it, what you'd have is a rectangle. And in my picture, this dimension would be the height, and the top dimension would be the circumference of the circle, and the circumference is 2 pi r. So that's where you get that little formula for the side of a cylinder. And you can imagine cutting it, getting a rectangle, and there's your L times W. Okay, a cone. A cone, again, has a few dimensions, but we're only going to worry about two right now. We're going to worry about S, and we're going to worry about R. And again, as with a pyramid, pyramids like cones have height, how tall they are, but they also have the slant height, so how long the slanted side is. And these two letters are going to come in to the formula for the surface area of a cone. So if you think of examples of cones, I think the first thing that pops into most people's minds is an ice cream cone. But also we could have a traffic cone, and maybe the tip of your pencil is a cone shaped. And the formula for the surface area of a cone is, again, it has two parts. It has this part and it has this part. And again, the bottom, or this first part, is the formula for a circle, and that's just the bottom. And this is the formula to determine the side, or the lateral side, of that cone. So pi times the radius of the cone times the slant height. And finally, our other curvy shape today that we want to figure out the area is a sphere. And in fact, a sphere is probably the easiest shape because spheres really only have one thing going for them, and that's the radius. So again, you have lots of examples of spheres, like any soccer ball or a tennis ball or a bowling ball. All these balls. But also, propane is stored, not your propane for barbecue at home, but propane storage at a refinery or how they transport it on boats. So if you ever see a ship sailing away, it's got funny spheres on top, that's holding propane, and it's there for a physical reason. And the formula for the surface area of a sphere, like think of the skin of an orange, right, is 4 pi r squared. So as I said, given that we're dealing with curvy circular shapes, pi is always going to be in our calculation, and you can use the pi button on your calculator if you want, or you can approximate it with 3.14. That's okay. So let's just do some quick examples of each one. And one of the things you're going to have to be careful with is making sure you're pushing the buttons correctly on your calculator, or at least we have a decent calculator. I'll show you my calculations. And I highly recommend you write down the formula whenever you want or whenever you are going to use it, and to either sketch or label a sketch. So I'm going to go ahead and label the sketch. Here's our cone, and we're going to have a radius of 7, and we're going to have a slant height of 20. Now, I wouldn't put in the units when you plug in your data because it kind of makes things messy. But remember, we're trying to find the surface area, and that's two-dimensional. So remember, our units are always squared when we have our final answer. So in going ahead and doing this, the surface area of a cone is equal to pi r squared plus pi rs. And I'm going to first plug in all my numbers. And then I'm going to get my calculator out, and I'm going to say the answer. So on my calculator, I can punch everything in, and I have a pi button right there, but I'm just going to use 3.14. And we're just going to round to one decimal place anyway. That's going to be our rule of thumb. So 3.14 times 7 squared plus pi 3.14 times 7 times 20. And when we hit enter, 593.5. So 593.5. And again, our units are always going to be square because we're talking 2 dimensions. So the surface area is not only on the side, it's including the bottom. And a nice thing to think about surface area, I mentioned with the sphere, the orange peel when we're talking about spheres. But imagine you dipped the shape in paint, and the surface area would be anything the paint touches. Okay, example number 2. Determine the surface area of the sphere with diameter 16. So this one's a little bit tricky because we're told something about the diameter of the sphere, but remember, in the formula, we don't have diameter, we have radius. So all we need to remember is diameter is 2 times radius, or radius is 1/2 of diameter. So our radius is going to be 1/2 of 16, which is equal to 8 millimeters. So again, You have to be careful with formulas. You have to make sure you plug the right thing into the right spot. So I'm just going to go ahead and go 4 times 3.14 times 8 squared, 803.8. So the surface area is 803.8, again, square millimeters. And finally, our last example, determine the surface area of a cylinder. Now, again, these have all practical examples. If you're making cylinders, you'd really have to know how much material, how much surface area you were going to have in order to know how much it costs you to make your cylinder, in order to know, hey, how much should you charge people. So our radius is 3 inches and the height of our cylinder is 12. And again, it's always a good idea to either make a little sketch or make a drawing. And then finally, we have 2 pi r squared, that's the top and bottom, plus 2 pi r h, that's the lateral side. And when we plug in our numbers, 2 pi times 3 squared plus 2 pi 3 times 12, and then we get out our calculator and we just punch those right in. 2 times 3.14 times 3 squared plus 2 times 3.14 times 3 times 12. 282.6. 282.6 square inches.